Hello. In this video, we are talking about the standard deviation of a population. So first of all, a standard deviation describes the spread of the data. How spread out is the data? So obviously, the bigger the spread of the data, the bigger the standard deviation is going to be. We can consider something an outlier if it's more than 3 standard deviations away from the mean, is usually how we define it. And those outliers can skew the standard deviation. So sometimes if you have an outlier, like we had in an earlier one where we had the weights of animals and they were all like below 160 kilograms, and then we had a horse that was 900 kilograms. So that horse would have been an outlier, and that would have been skewing our data, our standard deviation, making it bigger because it seems like the spread of our data is bigger than it actually is because we have this one just major outlier. So often when dealing with standard deviation, you will find the standard deviation, see if there's any outliers, and then get rid of those outliers and find the standard deviation again. We're not going to be doing that, but that's just general practice if you are using this for actual statistics. The other thing to know about standard deviation is we can have the standard deviation of a population or of a sample, and the formulas are very slightly different. In this video, we're going to be talking about the standard deviation of a population, but I will talk about what the difference between the two is. So basically, if you have a population, then you have all of the data. Everything in the category that you're trying to test has been accounted for. You have all of the data points for that set. So in this case, it's the weight of Newton's dogs. So we know the weight of all of Newton's dogs, not 3 out of the 4. We know all of them. So it's a population. It's a very small population, but it's a population because we know all of the weights that there are. If we were looking for the weights of all dogs or the weights of all of a specific breed of dog, for example, like if we wanted to know the standard deviation of the weights of all huskies, for an example. So we want to know the average weight of all huskies, and then we tested, say, 100 huskies. Then we would have to use the standard deviation for a sample because we didn't weigh all huskies. That would be impossible. We weighed 100 of them. We don't have all of the data, so we use the sample formula instead of the population formula. So with that all being said, let's actually look at what these formulas are. And I'll show you the difference, and then we'll go ahead and use the population one. So standard deviation, there are multiple symbols for standard deviation. I'm going to use lowercase delta for population standard deviation, which is pretty common. You'll see that in calculus or an upper level statistics class, like if you took AP statistics or if you took statistics in college, they would use sigma for population standard deviation. So that would be the square root of the sum from I equals 1 to n of xi minus x bar squared over n. That n is inside the square root, sorry. And I'm going to talk about all of these pieces and exactly how we find them in a second. But first, I want to show you the difference. So the sample standard deviation, which we usually use S for that, is going to be very similar. Sum I equals 1 to n, xi minus x bar squared over n minus 1 is the difference. So this minus 1 means that our standard deviation is going to be a little bit bigger, right? Because we're dividing by a smaller number, and that's basically taking uncertainty into account. Say, okay, I'm actually going to make sure that my standard deviation is a little bit bigger than I think it's going to be because I have this level of uncertainty. And that's basically the difference. That is the only difference between these two. So I'm going to go ahead and erase this one, and we're going to talk about the pieces of this one. All right, so let's start with what are even all of these letters that I wrote. So xi are just the data points. So that would be, so like this would be x1, this would be x2, this would be x3, and this would be x4. So I is going up from 1 to n, where n is the number of data points. So xi are the individual data points. N is the number of data points. So in this sum, we're saying each time it's going to the next data point, because I is what is increasing from 1 to n. So I is just a subscript saying first data point, second data point, third data point, fourth data point. That's all this is really doing. That's what the I is doing here. X bar is the mean. So that doesn't change. That's going to stay the same. So we're going to have each data point minus the mean and then square that. So we'll go through it in detail and you'll see. And again, this n is the number of data points. Delta stands for population standard deviation. This is lowercase delta. No, it's not. Why do I keep calling it delta? This is lowercase sigma. Did I call it delta earlier? I'm sorry. This is lowercase sigma. Lowercase delta looks like something like that, by the way. It's a little bit similar. Yeah, something like that. It's similar, but this is lowercase sigma. So the sum symbol, which I sloppily drew right here, this is uppercase sigma. Standard deviation is lowercase sigma. So yeah, you don't really need to know that. You just need to know that this means population standard deviation and this means sum. But I digress. Anyway, let's try actually calculating this stuff. So first we need to know the mean, right? Well, we already know n. N is 4. We're given that, right? 4 dogs. So n is 4. I'm going to write that up here just so we know. And we need to find the mean. So the mean is going to be the average of the 4. So we're going to add 6 plus 5 plus 13 plus 8 and divide that by 4. So that gives us 8 as our mean. This is very unwieldy sometimes. So 8 is our mean. So now let's go ahead and do the x minus x bar squared, this part. Xi minus x bar squared. And we're going to do the sum. I equals 1 to n. So the first one, x1, is 6. So we have 6 minus x bar is 8 squared plus the next number, 5 minus 8 squared plus the next number, 13 minus 8 squared plus the last number, 8 minus 8 squared. Oh, that's 0. That's nice. Okay, So all of this, 6 minus 8 is -2. -2 squared is 4. And so one nice thing about the fact that we're squaring all of these is it makes them positive. So we don't have to worry about signs. Everything is going to end up being positive. 5 minus 8 is -3. -3 squared is 9. 13 minus 8 is 5. 5 squared is 25. 8 minus 8 is 0. 0 squared is 0. We can just not care about 0. Okay, 4 plus 9 plus 25. So this is 38 is what we found here. 38. So that was the sum part. That was the numerator here. We got as 38. So the standard deviation equals the square root of 38 over n, the number of data points, which is 4. So let's do 38 divided by 4 is 9.5, or 19 over 2. So it depends on how you wanna do that. Yeah, so if you want to leave it as an exact answer, it's 19 over 2. Let's go ahead and find an approximation. So we're going to just put that in a calculator and get a decimal approximation. So that's approximately 3.082. This says round to the nearest hundredth, so 3.08. So that is standard deviation. It's a lot of steps, but it's really not that bad. The sum is probably the scariest looking thing on here. But once you realize you're just taking each piece, subtracting the mean, and then squaring it, that's really all you're doing, and then you're adding those together, it's really not that bad. It just looks daunting when you look at this formula. You're like, what on earth is going on? But if you break it down, it's really not that bad. So hopefully that helps. Hopefully that's clear that this is really not as bad as it looks. I'm just going to check the answer really quick. Yay! I like to check my answer in these videos because every once in a while I just do something incredibly stupid and I get the wrong answer, and then I have to do the video all over again because I got the wrong answer. Or if it was a simple mistake, then I can just explain why I got the wrong answer and then get the right answer. But sometimes it throws off the whole video and it's very, very sad. But that didn't happen this time. It's not like it happens a lot. I just every once in a while. But anyway, I'm just babbling now. So hopefully that helps, and I will see you guys soon.